welcome. This video is going to be shorter than the last video. I just have a couple problems, and then I have some pre-recorded videos that will finish off this lesson. All right, so we're taking the derivative of sine xy equals 1. All right, so this is going to be a chain rule, right? We have to take the derivative of sine blop, right, and then we take the derivative of the blop. All right, so derivative of sine blop is cosine blop. Oops, come on. Well, try writing that again. Usually takes me 2 tries to write things when I get started. So we have cosine blop. The blop is xy. And then we have to take the derivative of the blop. Right? So that's going to be a product rule here. And the derivative, of course, of 1 is 0. Right? So the derivative of xy is going to be the first, which is x, times the derivative of the second. So the derivative of y is dy dx, plus the second, which is y, times the derivative of the first one. Derivative of x is just 1, equals 0. Right? So now that product is multiplied by cosine xy. So we're going to have to distribute the cosine xy to both those terms. No big deal. So we have cosine xy times x dy dx is x cosine xy dy dx. I'll put the dy dx second. No, that doesn't make much of a difference, the ordering. It does look better to have anything that's not cosine in front of it. Otherwise, it starts to look like it's part of the argument for cosine. And then plus, we'd have y times cosine xy equals 0. We'll subtract the things that do not have a dy dx to the other side. So we have x cosine xy dy dx equals negative y cosine xy. And that's kind of odd. We're going to divide both sides by x cosine xy. And, whoops, what the heck? I guess I hit the board. Whoop, got a really long line here. And I think that's going to reduce on the other side. So we've got dy dx equals negative y over x. How about that? The cosines dropped out when we simplify that. Well, that's an interesting little derivative. I didn't expect the cosines to drop out. All right, so let's try the next one. All right, so we want to find the equation of the tangent line. Very first thing we're going to do, and I believe yours has it written in, the point was 9, 4. All right, so you can't find the equation of a tangent line unless you know where. So it's at 9, 4. All right, so let's first of all change the radicals to exponents. So x to the 1/2 plus y to the 1/2 minus 1 equals y. All right, so the derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2. The derivative of y to the 1/2 would be 1/2 y to the negative 1/2 dy dx. The derivative of 1 is 0, so I'm not going to even bother to write it in. And the derivative of y is dy dx. Right, so I have, since there's already a term on the right-hand side with the dy dx, let's just move the other term with the dy dx to go with it. So this would be 1/2 x to the negative 1/2 equals dy dx minus 1/2 y to the negative 1/2 dy dx. We will factor out the dy dx. And I'm going to change that x to the negative 1/2. I may as well at this point make that a radical. 1 over 2 square roots of x equals dy dx. And then we factor that out. So dy dx divided by dy dx is 1. minus, and this is going to be 1 over 2 square roots of y. Right, so we're going to divide both sides of our equation. You can see we're going to have a complex fraction again, but you saw it was no big deal. So we'll divide both sides by 1 minus 1 over 2 square roots of y, and then we'll just simplify it. So we have 1 over 2 square roots of x over 1 minus 1 over 2 square roots of y equals dy dx. Right, so now you see we've got a 2 in the denominator, we've got a square root of x, we've got a square root of y. So we're going to have to multiply by all of those things. So every term gets a 2 square roots of x times y. Is the square root of x times the square root of y is the square root of x times y. Right? You can multiply radicals so long as they have the same index. So you can multiply square roots by square roots and cube roots by cube roots and so forth. So every term has to get a 2 square roots of x, y. So there's one term in the numerator part, and there's 2 terms in the denominator. So you get a 2 square roots of xy, and you get a 2 square roots of xy. So that will cancel the 2 and the square root of x. That's going to leave a square root of y. And I'm going to just put the dy dx first. So dy dx is equal to, in the numerator, we are left with a square root of y. In the denominator, well, 2 square roots of xy times 1 is just going to be 2 square roots of xy. And then the second term, the 2 will cancel, the square root of y will cancel, but the square root of x is left. So square root of y over 2 square roots of xy minus the square root of x. There's our derivative. Okay. And then we need the slope of the tangent line, and then we can write the equation. Right, so we just plug in a 4 where we see a y, and an x where we see a 9 where we see an x. Right, so this part here, this was all the derivative. Now we'll find the slope of the tangent line. Right, so that's just going to be dy dx at 9, 4 is the square root of 4 over 2 square roots of 9 times 4 minus the square root of 9. These numbers were well chosen. By the way, this is a point on this curve. Dy dx, but I didn't choose just any point. I chose a very nice point. Square root of 4, 2, and then we have 2 square roots of 36. Square root of 36 is 6. I think you're okay if I do that, right? Minus the square root of 9, so that's minus 3. So that's going to give us, our slope is going to be 2 to 12 minus 3, so that's going to be 2/9. There's the slope. And now the equation of the tangent line. Right, so y minus 4 equals 2/9 times x minus 9. Boy, that one really simplifies nicely in a slope-intercept form. Maybe we'll just simplify it in a slope-intercept form. Y equals 2/9 x. 2/9 times negative 9 is going to be a negative 2, and then plus 4. So the equation in slope-intercept form, 2/9 x plus 2. Couldn't get much nicer than that. Right, and we're done with this one. Right, so now really it's just using the derivative rules, isolating dy dx, and then a little algebraic manipulation sometimes. This is the last one that I'm going to do on this video. The other ones are on the next videos, including the second derivative. All right, so here we have 25. We're going to take the derivative, and we're going to find horizontal and vertical. We're going to find horizontal tangent lines and vertical tangent lines. And the video, this particular video, we are just going to find the horizontal tangent lines. Our very first step, though, is to take the derivative. This is actually a pretty easy derivative. Derivative of 25x squared is going to be 25 times 2, so that would be 50x. Right? You just multiply the coefficient times the exponent and reduce the exponent by 1. Just a little power rule there. Plus, derivative of 16y squared would be 32y dy dx. Derivative of 200x is 200. The derivative of negative 160y would be negative 160 dy dx. The derivative of 400 is 0. The derivative of 0 is 0. So that's all our derivatives. We'll move the terms without dy dx's to the other side. So we have 32y dy dx minus 160 dy dx. I don't know why I put a line there. Equals negative 50x minus 200. Factor out dy dx. So that would be 32y minus 160 equals negative 50x minus 200. And then divide both sides by 32y minus 160. So dy dx equals, and we should really reduce this, they're all divisible by 2. They'd be divisible by 4 except for the 50, or by at least 10. Yeah, 10 if it wasn't for the 32, but all of the terms are divisible by 2. So this would be negative 25x minus 100 divided by 16y minus 80. There we go. So there's our derivative. All right, so on the next slide, I have about finding horizontal tangent lines. All right, so our slope, so a horizontal tangent line means that the slope of the tangent line is 0. So when is a fraction equal to 0? When the numerator equals 0. Right? So this slide is actually the last slide on this video and the first slide on the next video. So I already have it all written in for you. All right, so we set the numerator, which was negative 25x minus 100 equal to 0. And we solve for the only variable we have, x equals negative 4. So there is a horizontal tangent line at x equals negative 4. Right? To find the rest of that, right, so remember before the derivative was negative 25x minus 100 over 16y minus 80. And your so a fraction is equal to 0 where the numerator equals to 0, right? Or you could plug 0 in for dy dx, and if you cross multiplied, you'd still get 0 equals negative 25x minus 100. All right, so horizontal lines have 0 slope, but we need to find the y value. So we're going to substitute x equals negative 4 for x in the original equation and solve for y to find our points. Because we're looking for where the horizontal tangent lines are, and it's not enough to have just the x values. So 25 times negative 4 squared would be 400, plus 16y squared minus 200 times negative 4 would be 800, minus 160y plus 400 equals 0. Well, the constants cancel themselves out. You've got 16y squared minus 160y equals 0. Factor out greatest common factor is 16y. Set those equal to 0. So y 16y is 0. We got y 0. Y minus 10 is 0. Y is 10. So there are horizontal tangent lines at negative 4, 0 and negative 4, 10. Okay. On the next video, we'll find the vertical tangent lines. And then we'll take a look at what this function looks like, just so you can see, yep, that's where the horizontal and vertical tangent lines are. All right, so bye for now.